Thank you very much, guys. It's very welcoming. Yes, and also nice to see what we have almost no available seats for those who are listening us online. Yes, so today I will be talking about our experience in flexibility studies. Some of you may hear flexibility is the urgent topic. We have to integrate, we have to use it, but we don't know what it's about and how to apply it in the system. So also I will talk about, let's say, another system actors, power system actors, how we can deploy flexibility in more efficient way. And my presentation is based on the projects and cooperation and international cooperation of our department within the NTNU and also within the smart grid team. So the main topics of my presentation will be built around system operation and security. I will touch also aspects of transmission and distribution grid. I will talk about the flexibility and the role of flexibility in modern power grid. Also, I will talk about different elements coordination, and this will be based on different examples from the projects and studies I've been involved. So first question is, when we talk about flexibility, what is flexibility about? And what is the background to flexibility needs, and what is the categorization of it? So flexibility, it's not a new concept. You know, power systems have to be balanced, keeping the frequency at 50 Hertz. So basically we generate and we consume the same amount. So this is the idea of flexibility, which was not a new. But nowadays, we see what flexibility is not a unified concept. It's kind of the umbrella covering different various needs and aspects in a power system. Some backgrounds to understand from where is it and why it is. We have currently two major trends integrating renewable energy sources. They are uncertain and volatile. And for instance, starting my research about 20 years ago, we were kind of struggling to integrate more renewables of the system because they create troubles, because they are volatile, and we want to keep frequency stable. So why do we need to integrate them? But now we reach another stage of that. So we see what renewables can really help with the volatility and with the available flexibility in the moments we need it in a particular and specific part of the power system. So basically, we can integrate them into the operation, but then it needs to be properly planned in advance and calculated, of course. Also, when we're talking about such type of aspects of flexibility, we need to understand we need technology to do it. So we basically need innovative technology. We need communication and monitoring technology because we exchange the information. So we need the ICT included. And then to utilize this, we need to have financial incentives. So we need to have a platform where we can apply and award our, let's say, flexibility providers or those who are interested in that, in application of that. Therefore, in 2018, we have developed the scale. We use still for different purposes, let's say, mapping the flexibility needs. So it's contain 4 different groups of flexibility in terms of time. So we start with the, let's say, milliseconds with the devices we use for monitoring. And then we talk about the system needs at the minute scale. And for instance, in the market scale, then we talk more about on an hourly perspective. And from the planning purposes, of course, we have the bigger scale, we take days or years. And to give you an example of what does it mean, I can demonstrate this, let's say, flexibility solutions. Here are different technologies are mapped according to the 4 groups we have developed. Basically, different services located at different grid levels. It could be distribution, it could be transmission or system level, and then also different devices or activities could be performed and classified. I think it's a very good also material for those who are working with flexibility. And down you can see the link, you can download the report and you can read it in the details. So then we defined the flexibility and we were trying to use it. We see what actually we cannot really rely on that because it's intermittent, it's flexible, and we don't know how to activate and how to trust. And then we basically came to the next level of flexibility. We talk about operation-oriented flexibility to security-oriented flexibility. So we want to know when we want to use it and how to activate it. So, and we need to trust, because from the system operator point of view, we have really very short time to decide to activate the different units generating extra power we need to support the system. So therefore, we talk now about the next level of flexibility. And then the new term came, it's resilience. So basically, we have a lot of elements. We have a lot of actors in a power system which operate and communicate to each other. So we came to this idea that they need to be resilient. The concept covers also quite wide spectrum of the terms and definition, but what is the important part? So we have to be ready for different events. So yes, we understand how the system behaves from the technical point of view, but what about weather condition? What about cyber security threats? All these also need to be involved in or assessed during the planning stage as well, and need to be involved with the different types of criteria and maybe objective function as well. So each stage and approach is very important and require really the deep dive. But these are not kind of the completely new. You can see also a lot of publications now available and a lot of demo sites available at the system operator side. So basically we are learning how to do it, and the future is quite bright in that way. So, but this is here as we talk about the next level of flexibility. And then, of course, when I talk all about the system, but you saw also we have an user's perspective. So how we can see it in a common plane. So this is kind of the map in a very simple manner when we can see main actors of the power system, starting with transmission system operator and distribution system operators, flexibility providers, and consumer. So what we need to make them work together. So first of all, it's communication. So we need to have proper ICT channels. They need to communicate, and they need to be rewarded for that communication. So if end users is interested in the flexibility provision, and users need to be rewarded on that. And these mechanisms should be clearly defined. Therefore, market design and different market platforms are very actual topic now. And also in Norway, we see a lot of companies like Spin-off also working in this direction and contributing to this topic. So it's also very, very interesting and challenges. So far in Europe, we see a lot of demo sites and pilots. Maybe it's not well integrated, but it's make our work really excited. So it's really, really a lot of engineers are needed to apply this in a real life. Another maybe getting back to this, let's say, how to coordinate activities, having so many actors involved in a system work, they need to be coordinated. And therefore, we have developed a coordination scheme, TSO-DSO coordination scheme, to make it clear also between actors and actors how they can ensure flexibility. For instance, if we see sources connected at end user level or distribution level, and we want to use them at the system level, we require proper coordination between these mechanisms. And this is also something new. This scientific direction began about 5 years ago, but system operators are learning quite fast, and we see already very good examples on that, but still, again, it's not maybe very massive implementation on that. And I also put a link to a research article. We'll be working in this topic. And maybe another one is important I want to highlight is market platforms. We talk a lot about market design, but I don't see we need any specific change in the market design, but we need more different market platforms to activate flexibility and to make, let's say, end users to cooperate in a proper manner. And therefore, this type of platforms may have different coordination option and different, let's say, type of organization, and the points they serve are also demonstrated here. And another one from the ICT aspects, so it's super important to keep a reliable data exchange between all actors. A lot of discussions now also within the cybersecurity aspects. And now also at our department, we have started this initiative. We work also on a cybersecurity from the power system perspective. It's very interesting and challenging topic, and we really hope to have more good results. So we started about 1.5 years ago on that. And maybe also coming to the end, I would like to highlight our another initiative about an end user role and local energy communities role. I've been taking part on the work initiated by ETIPSNet, a European Technology Innovation Platform on the smart networks. The report is focusing on consumer engagement and role of energy communities, also in the connection how they can provide, for instance, flexibility services and how they can be active contributors to facilitate power system operation. So it's also a good source for those who are working in a topic, maybe to look into it. There are interesting demo sites also given there. And then also, yeah, we have very short time. I'm trying to speed up. From the, let's say, summary point of view, collaboration between different system elements and actors are super important. We also learning, we work a lot on power system design related topics, but coordination is super important. Then from the regulatory point of view, there is a need for common rules and market mechanism platform. So it should be clearly defined and available to all end users as well. And then also flexibility technologies and services. I think it's a really actual topic. There are many things happening already, and I think still more researchers needed incorporating, for instance, storage technologies in these concepts, EVs, and maybe using artificial intelligence as a supporting tool for this type of studies. As well as to engage end users, we need to have business models, and I guess the next speaker will talk more about that, but we really emphasize we really need good business models to activate flexibility. And of course, it's require consumer engagement, co-creation, replicability, and upscaling. And at the end, it should lead to the standardization. We have to have standard solutions to deploy it in the right way. Maybe as the final slide, I want to show we have 2 years ago, we have launched a new specialization course when we have one special block targeting flexibility in power grid operation and planning. And there we are learning our students on flexibility concepts. And also we show different calculation examples, how we can calculate if the grid is flexible and what is needed for grid to be flexible. Yes. So I think I'm on time. Thank you very much. Looking forward to questions and discussion.
Thank you very much, Irina, for this good overview of flexibility. So we look forward to discussing this further with you. But for now, we will move straight into William's presentation. So William Throndsen is a researcher at the Department of Interdisciplinary Studies of Culture. So William has participated in studies of electric vehicles and their smart and traditional charging methods. He's currently leading the Green-Black project, which examines transition in the oil and gas sector, with a particular emphasis on the role researchers have played in and the funding sources that drive this research. But his main focus has been smart grids, right? Notably during his PhD, and he tries to understand how smart and innovative energy technologies can influence energy consumption patterns at both household and commercial levels. So I think we'll be in good hands for exploring end users' contribution to smart grids. I now hand over the floor to William.
Thank you for that warm introduction. So yes, let's see if this works. Okay, so yeah, let me start by telling you a little bit about flexible end users in the smart grid, and more specifically how engagement strategies and co-creation can be employed in smart energy technology projects. I'll begin by giving you a short overview of the SENDER project. 15 partners working across several countries with 3 demonstration sites. So there's one in Spain, there's one in Austria, and one in Finland. The project, which is more or less finished these days, was a project aimed at developing smart grid technologies for households, such as virtual thermal energy storage using devices such as heat pumps and water heaters. There was a vehicle-to-grid technology with smart charging capabilities. There was a communication gateway to put inside the household with a front-end application with user interfaces through the web and with a mobile phone between end users and the electricity markets for controlling demand response settings such as hot water and indoor temperature and stuff like that. And also there's a bunch of sensors implemented to get data about stuff going on inside the household in real time, like motion, temperature, air quality, what have you. Okay, so now for something completely different. Within technology development such as this, there's a lot of expectations leveled towards end users. Users should be active parts of the market, meaning they should do peak shifting, peak shaving, load shifting. In other words, move their electricity consumption around to hours in the day when there is more electricity available in the grid. Because a flexible consumer is postulated to allow us to make better use of the grid itself. And sometimes they're even expected to produce their own electricity using, for instance, solar PV, making them into prosumers, and even to trade electricity amongst themselves. And TSO and DSO actors really hate this. So leaving aside the technical and regulatory challenges to all this, can we even expect the users themselves to do all this? After all, they're just regular people living their daily lives in their houses. So what do we need the users for? Traditionally speaking, technology design, economic market thinking, these things have really been the main powers shaping much of our understanding of users as electricity consumers, rational actors who actively seek out and use all the tools and information at their disposal. However, what this conceptualization ends up missing is that what we're really doing is not consuming energy. We're cooking food, we're washing clothes, we're showering, we're heating our homes, we're watching TV, and all that other everyday stuff. So, in fact, if you think about it, electricity is really itself invisible. And this makes it really hard for us to actually experience energy use as such, meaning how many kilowatt hours am I using for washing these clothes or making this food or what have you. So this makes it challenging, to say the least, to change consumption patterns, which is the ambition of smart grid technologies. And the expectations I mentioned earlier about smart energy consumers is by a large degree invented by technology designers. So they envision people that are eagerly trying to be the kind of people that they're envisioning, if you can see it. So this really just has the problem that it leaves out exactly this, which is everyday life mess. Real life is not really sufficiently described as a technical problem. And this is also why economic incentives are not always effective in changing energy consumption behavior. So how do we create smart grid solutions for households that work in practice? One way to do this is by including the end user in the design process. So this can be done by doing what's called co-creation. And in this book, called the co-creation paradigm, is where we find the concept as it's implemented most commonly today. They define the co-creation as the practice of developing offerings through ongoing collaboration with customers, managers, and other stakeholders. This means consumers are placed at the heart of value creation. Users collaborate, basically, in value creation. And this, again, is supposed to offer individuated experience. It's supposed to generate new ideas for designs, ultimately leading to more benefits being reaped from using the product. And this isn't really just a single methodology or even a collection of methods, such as focus groups, surveys, doing ethnography, workshopping. Even though it does all of that, co-creation is mostly committed to open product development and user participation. And although it's coming from the world of business or product development, more recently, it's also found its way into research and science-based technology development projects, where it resonates with democratic issues like open science or citizen science. So in short, when we answer calls and write research proposals, this is one way to address those concerns. In this project, the SENDER project, we've been doing co-creation from the very start of the project by taking the technical aspects of the project and saying, okay, what will it mean for a person or a household in practical terms to have these technologies in place in their everyday life? For instance, how will a person experience having certain kinds of demand response actions undertaken in their homes when they get up in the morning or when they are at work or when they come home from work? What decisions will be taken for you as a person going about your daily life? So together with the technical partners and the other stakeholders that we involved in the project through the establishment of a co-creation steering group in the middle there, we boiled this technology down into little narratives about how life would be like with these solutions in place in the household, which we then ran by the end users by way of workshopping. And this allowed us, in a way, to reality check a little bit what we had in mind for our users, and more generally, what would users be okay with? And in our case, it made us able to say, okay, at least we're not doing something that's completely impossible for people to comprehend or relate to. So co-creation is useful for getting a sense of are we on the right track with our use cases? Is what we're doing, is what we're going to impose on and expose these poor demo participants to something which will be possible to justify and explain to them. And even you're also better prepared for possible objections from the users when you start bothering them with this. So there's also this added bonus that because you're doing co-creation in the project, we were given an opportunity to work together in the project on the use cases in a very concrete way. This enabled us, all the stakeholders, to be much more aligned about the solutions that was being developed. So co-creation is not just something that goes on between the projects and the users, but also between the different solutions, the developers, and other stakeholders within the project itself. And this creates a much better overview for everyone about all the different parts of the project. And sometimes in these projects, many solutions are, of course, brought on board, more or less in a finished state, existing assets that people have, what stakeholders bring along. So there's maybe not a lot of scope for changing them. But even so, doing co-creation increases what you know about how this specific design will work. And it means you can still improve what you're doing without actually making changes to the technology itself. Engagement strategies. We've developed co-creation use cases, included user feedback through several rounds of workshops, and we're ready to start the pilot and implement our finished technical solutions. This is where you go from workshops to maybe hundreds of households, and that means you need an engagement strategy. So the strategy employed in the SENDER was threefold. First, it was a recruitment phase, which encompasses all the moments in which a potential user is exposed to information that's relevant to participation in the project, all the way up to the moment where they sign up and they want to participate in the pilot. This ranges from learning about the existence of the project, but also about flexibility services and demand response in general. Like, what are these technologies that we're trying to implement? And you hold events and webinars and stuff where people participate and the details of the project are presented. And then in the middle there, that's the consumer response phase. Strategies here are directed at initiating and consolidating behavior change and response to flexibility demands. So this phase would start when the user's own acts of planning and reflecting how to rearrange domestic energy use practices, as well as installing any kind of new technology into the households, leading to a state where participants are at least somewhat conscious about what the use cases mean and what is supposed to be going on. And in the third phase, the persistence phase, is about sustaining interest, keeping them on for the long run, and continued participation across the duration of the project. Ideally, we should arrive at some long-lasting and permanent change. So the ultimate goal of this phase is, of course, that participating in the project is sufficiently interesting and comfortable for users so that they may be willing to maintain any behavior changes and continue to use these technical solutions that you've implemented once the project is over and beyond. To conclude, I will summarize some of the lessons learned not just by this project, but also similar neighboring sister projects. And this can also be explored further in this paper. So first off, it's good to have a set of diverse engagement strategies, meaning you employ a range of strategies that's tailored more or less to give you a more impactful user engagement. So this is where data from the co-creation process comes in handy. And the next step is to have a phased implementation, meaning that you organize engagement strategies into distinct phases, like in the last slide, making you more efficient and more adaptable. And of course, you align all these phases to the timeline of the project. Then there is this keyword utilization. It's a bit tricky, but the idea here is to incorporate targeted keywords relating to everyday life, and that connects the technology you have to the everyday life. Stuff that you know resonates with the motivation that people have already for participating in the project. Make sure you're adaptable in crisis, so be prepared to adapt strategies during challenges, particularly in the face of unforeseen circumstances like a pandemic. Also keep in mind the value of money as it keeps changing for some reason, and suddenly you're not as rich as you thought you were. So when it comes to motivation and eligibility, you have to make sure to craft recruitment materials that engage and resonate with people's motivation to engage in the first place. So this just means know your customer. And basically, what is their motivation? Their motivation is what makes them eligible to join. So the next is to keep doing continuous assessment. So you need to keep your ear to the ground, basically, by visiting demo sites and ensure community needs and your support structures are aligned. Then you have sustained collaboration. So you would foster collaboration and knowledge sharing among project partners. So different actors can make use of shared experiences when they engage with the field. Finally, then there's this issue of overcoming barriers, and this is really important to proactively address any kind of barriers at an early stage, because in these kinds of projects, the technology that you implement today are expected to keep working for decades, which is a tall order. So to sum up, these kinds of projects are really complex. This requires that we integrate several highly detailed kinds of expertise, different knowledge domains, including users who are, of course, experts in their households. And it means it's important to identify and bring together all the relevant stakeholders, perhaps in a co-creation process, so that can ensure that we implement a democratic and also, not least, a useful smart grid. Thank you.